All right, this is paper 3 from 2016. We're up to problem number 3. Continuing. Problem number 3 uses the mean value theorem, which is a theorem you need to know how it works. So I've got it set up over here graphically, and then we'll also write out the definition for the theorem. So mean value theorem, what it basically says is if you take any 2 points on a continuous differentiable curve and find the slope between those 2 points, that somewhere between those 2 points there's another point where the derivative is equal to that same slope. In other words, the slope at that point, the slope of the tangent at that point is the same as the slope of the segment joining A and B. So if we write that out formally, what that says is that the derivative at C is equal to f of B minus f of A over B minus A. What I just wrote, f of B minus f of A over B minus A, is the average rate of change. So that is the slope of the segment. That is the mean value theorem. Now that is for when C of course has to be between A and B. So in the interval from A to B. Okay, so what we're trying to do is use that theorem to show something about a particular function that was given, which is ln of x. So the trick to this problem is just use that basic definition and apply it to ln of x. So f of x equals ln of x. And I'm going to use that derivative in a minute, so let me go over here. This is my reference page. So f prime of x equals 1 over x. So I'm going to use those two things in just a second. So f prime of c is ln f of b, which is ln of b, minus ln of a over b minus a. So all I did was sub in a and b into the function. Now that's equal to f prime of c by the theorem for some c in between a and b. Now I'm going to change this a little bit. I'm looking at what I'm trying to get, and I see ln of b over a. Well, I know that log property, so the numerator ln of b minus ln of a is ln of b over a over b minus a. Okay, now that has to be between, well, let me set it up this way. We know that f of a, rather, scratch that. We know that c is greater than a is less than b. Look at your diagram again. According to the theorem, c is in the interval from a to b. So f of a, or f prime of a rather, we're trying to set up the relationship here is because we're dealing with the derivatives in just a second. And f prime of b, we want to see how these things are related, and then f prime of c. Well, we know that that's between somewhere, but since we're dealing with the derivative, and the derivative is 1 over x, if you think about what 1 over x looks like graphically, you know, of course, when x is 0, it's undefined, so the graph goes like this, and in the original instructions, we know that everything's greater than 0, so we're only concerned with that portion of the graph. And when a is less than b, if a is here and b is here, you know that the derivative at b is less than the derivative at a. So what happens here, we just write our little comparison like so. Whoops, I drew it the wrong way. I just said it. Just said it right. The derivative of f of b is less than the derivative at f of a, f prime of a. Okay, now let's just sub in everything. F prime of a is the derivative at a, which is 1 over a. F prime of c is what I just got a couple seconds ago, which is ln of b over a over b minus a. And f prime of b is 1 over b. Now, let's glance back at what we're trying to get. It's starting to look like that a little bit. But now I want to multiply through to get rid of that b minus a. I'm going to multiply both sides of this inequality by b minus a, so I get b minus a over a is greater than ln of b over a is greater than b minus a over b. Well, that's pretty darn close to what we were trying to get, except the n's are different. But if you look at the inequality signs, if we just reverse everything and flip it, we're going to have what we're trying to get. So yeah, we've got it. It just needs to be reversed. So b minus a over b is less than the natural log of b over a is less than b minus a over a. So a little tricky on the signs and setting up the mean value theorem. But if you know the basic theorem, you can get most of this problem without any problem at all. So be sure you know what the mean value theorem is and what it says, because every once in a while they'll throw that on these tests. Now this last part of 3 is real easy. If you just look at the previous part that we just got, what we were supposed to get, which we got. So it says show that ln of 1.2 lies between 1 over m and 1 over n. So the natural log of 1.2 is the natural log of 12/10. You can think of it that way, which is the natural log of 6/5. Now, according to the previous result, the natural log of b over a, there's b over a, is in between b minus a, which would be 6 minus 5 over b, 6, less than b minus a, which is 6 minus 5 over a, which is 5. And we'll just clean this up and we get 1/6 less than ln of 6 over 5, less than 1/5. So we just showed that ln of 1.2 lies between 1 over m and 1 over n, where m and n are consecutive positive integers, which they are. They are 5 and 6. So let's get our order right here. M equals n equals. Well, I guess it really technically doesn't matter in this case, does it? So we'll say m equals 5 and n equals 6. And that is done.